Help us out, yeah? It's called We're in This Together.
Okay, so we have the primitive types in neurUL, and we have the method of combination, and we have the method of abstraction. So what is abstraction? Abstraction is basically the idea that you can represent certain concepts without knowing the internal details about the concept. So let's say in the example from this class, so I'll just post the link here as well. So in the example from this class, what it's doing is, let's say you have a square root, right? Or let's just say square, right? So square is basically saying the same number multiplied by itself, right? So abstraction is the idea that you can call things without knowing how it's being done, right? So let's say you have a coffee maker at home, right? You say make coffee, and all you see is just a single button, right? And the abstraction concept allows you to create coffee without actually knowing the exact details of how that is then done in the background. So that is abstraction, and that's a very important concept, because using that, we are able to create immensely complicated systems without worrying all of the details involved in a certain process. So a pilot, for example, can fly a plane using just a set of controls on a dashboard. When you think about it, the plane itself is a combination of thousands of different controls happening in the background, being automated for the pilot himself. And that is being used by our bodies as well. So when you're walking, actually all you're triggering is possibly the neuron walk. But the different muscular systems, the different circulatory systems that need to be coordinated for that purpose is abstracted from you. So you don't need to think about that. All of the necessary thoughts to coordinate all of that is simplified. So if you watch this video, that's what's discussed basically. So the primitive types, the method of combination, and the method of abstraction. So that's one topic that can be discussed in the next session. However, the problem that I can see with that is it might be too technical. So if you see this video, I would say, I think you can just watch the first 40 minutes and that's it. But the challenge is that it has, I would say, 10 minutes of mathematics, which are, not really that basic. But I think it's fine. It's just a matter of getting through them, and maybe we can just tell, those who are interested in attending the next session that, they watch this video, but just feel free to ignore the mathematics involved. It's just the idea that needs to be understood behind. And another topic that can be discussed is neurUL for English. And so this is, how do you represent basic information? Because if neurUL can represent anything that you could imagine, so let's say a server. Okay, I'll just open this one. I'll just open it, just give me a second. Right. So imagine the concept of a server. So what is involved in a server? Oh, okay, it's not loading. Let's say just an avatar server. And Let me just look for a good example property, this one. Okay, has a name of string, has a name of string. Who has a name of string of avatar? Right. Okay, so let's just pretend that this is the concept of a comment on Facebook, right? So, okay, right? So a comment on Facebook has a value of string, and then it can have a value, oh, sorry, it's not a good example. Let me just expand this. Right, this is it. Okay, all right. So as you can see, we're just using the neural structure and the neural processes, and then we combine them gradually to create a concept. So let's say this one is a grandmother cell or is an extension. So, right, what is a server one? Just bear with me because it will look a bit complex at the beginning, but let me just explain how it is, all right? So, okay, what is server one? Just by reading the neural network, we can see that server one is a type of an avatar server, okay? It has a name of string of avatar server of server one. So this is like saying Elmer has a name of Elmer and of Bool. So if we expand this, you can see that this is just combining different ideas gradually as well, right? So it has a name of string of avatar server of server one. So we're concatenating, we're gradually combining ideas to form one grandmother cell at the top. So server is my server at home, and it has a name of server one, which is this one, and it has a URL. So you can access this URL by going to this link here, neural.ngrok.io, which is this one here. Right? So this is how neural uses the neural structures and processes to create grandmother cells for perceptions. So that's why we're saying we can represent English sentences and English phrases and statements using neural. And if we maybe defer this topic later on and then go through this topic first, then we'll be able to show that you can use neural, for example, to store very basic information like to-do notes, just like what I've done here. I have used neural to manage the to-do list of this project itself. So if I extend this, let me just change the orientation. You can see that all of the tasks in neural have been managed in this way. So by doing this, I can immediately see, for example, which neurons are done, right? So at the moment, I have 4 items or tasks that are already done. And we can also see the other tasks which are still in progress. So you can see here, these neurons here extend from the in progress tasks. So I'm already, just by understanding how neural can be used to represent perceptions, then the user can already create a system based on that approach. Right? So that is a more basic topic that we can go through. So for representing perceptions. And the user can, for example, if we discuss this in the next session, then we can have a hands-on session after that, or maybe in that session itself, so the users can use neurUL already and use it for any purpose that they want. So they can, for example, they can use it to manage their grocery list, or let's say their notes, their day-to-day notes, their ideas, their tasks, or as a to-do list as well. So it gives immediate benefit to the user. Also, the only drawback is that, yeah, the app is very basic at the moment. So it may be a bit difficult to use, but being an open source project, we'll endeavor to make sure that the requests for changes are provided as soon as possible. All right, so that's for representing perceptions. And the other approach is to use neurUL for programming. So this topic here is actually, this subject here from MIT actually discusses how to create a programming language. And just by going through this video, you will see how really simple it is. I mean, though it's obviously challenging, but really simple it is to replicate Lisp, or the language which is being discussed in this topic, using neurUL. So I'll be able to show, if we discuss this, I'll be able to show how it is done. Right, so any thoughts? Do you think we should prefer one over the other, or do you think there's something missing in the next session? Or, yeah, from anyone? Please feel free to provide any input.
Perhaps we can just go ahead with the video.
This one, this MIT video.
Yeah.
I see. Okay, because are you thinking that we might as well optimize the apps first before exposing this? Because at least it'll be easier for the users who want to use it.
Okay.
I mean, was that the reason, Sel, why you wanted to go for this video instead?
I was actually thinking there will be some form of the more we listen to the video, we get certain insights from introductory perspective, so that as we drill deep, it would make it much clearer. But then again, feel free. I'm just suggesting.
Mm-hmm. Okay. Yeah, I really want to go for the video as well, coming from a developer background, because any developer who will see this video will immediately see that we are really only improving existing ideas using biological facts, and neuroscientific findings. So I think neurUL for programming is a good next step. The only thing holding me back with going for that approach is it might be too complicated, and I don't really know. I think the only way to really know is have users go through it and see what's there. Yeah. Sorry, Sal. I think you're.
Yeah. Any of them really works for me. I'll just tag along.
Okay.
I don't have a preference, to be honest.
Okay. All right. How about the other guys? Michael, Richard, Mattias?
No, yeah, so far so good, I think.
Okay. You would prefer programming as well, or either?
I think, yeah, kind of like getting into a deeper understanding of how the programming structure works,
Okay.
how you've built it to work. Because then you're going to have a better understanding of the difference compared to other programming ways and stuff like that.
Okay, I see. Okay. Yeah, okay. Richard, Mattias?
I don't have a preference.
Yeah, see, please go on. Mattias?
Yeah, I was just saying I don't have much of a preference.
Okay, all right. And Richard?
Me too, but I think the neurUL. I just send a word in the group chat.
Okay, yep. Sorry, let me just open that. Yeah, so language processing, right? Yeah. And I think that's really yeah, so the message from Richard is that neural for English really sounds like a topic for deep NLP, and I really agree. I mean, I think one of the things that is really interesting is that each of these two topics can really branch out into their own directions. So neural for English can go to data analytics, big data, and RDF or semantic web. So those are really deep branches that you can go through. Neural for programming can combine NLP and semantic web, and it may actually replace or improve programming languages as we have them at the moment. Because if you look at Lisp, which is one of I think the second language that was invented 1950s, it can really do anything. I mean, if you watch the video, you will see that all programming languages are basically syntactic sugars for the other languages. And yeah, so it can really simplify software development. So that's the potential that we're exploring in neural for programming. Okay. Okay, so I think since I think there's a majority going for neural for programming, so I guess we can go for neural for programming. And then I'm considering the fact that the app itself, the tool that we're going to use to manipulate the neurons, is not that mature yet. It's really very basic at the moment. I think, yeah, we can defer neural for basic languages later on. Okay, so neural for programming, and this means then that I'll have to improve this app a bit. There's another component of this app, which is the spiker. I'm not sure if everyone has seen that app, but basically that app uses the action potentials to process data. That means then that I'll have to merge that here so that maybe we can discuss that app during this same session. So, yeah. Sorry, there was a bit of a lag on my PC. Can you hear me?
Yep, I can hear you.
Okay. All right. So we will look at the Neural Studio in this session. So basics, how to use it. and then we'll see how we'll basically discuss the video Q&A regarding video, and then after we do a Q&A, basically to clarify the first 40 minutes of the video, there is actually a very important point in the video that I'm going to highlight. It will be a surprise, and me and my wife are discussing a good prize for anyone who answers the question in our session. So there's a very good point there. And this is just to encourage, the participants of the next session to look for that hidden clue or hidden idea which is related to neurUL. So there's a bit of a game in the next session as well. And then after we do that, we'll then see how we'll use neurUL to code the examples that will be mentioned in the video. To code examples in video. So the coding language which is used in the video is called Lisp. So you may want, if you like, after this session, you may check Google about this programming language, and it's a very basic language, but very, very powerful in data science, especially in AI. And what you're going to see in the video is that they have actually been thinking of the same ideas that we are in neurUL. The only thing was that they didn't have the neuroscience findings yet to go for the approach, but they were thinking of something similar 40 years ago, and that's really interesting. So neurUL code the examples in video, and then neurUL Studio basics. So how do we use this tool, this IDE, to code neurUL apps? So perhaps let's maybe create a use case, maybe for home security, or we can use the heart rate app as well. Okay. So that we'll discuss how the heart rate app, we'll discuss its architecture and the details of the implementation of how heart rate values from a heart rate sensor is mapped to a response in the neural network. Okay. Is there anything in this list you think that should be excluded, or are there ideas that you think should be added? Or is it too much or too little for the next session?
With the coffee shop or the coffee maker thing, could you explain that a little bit more?
Oh, sure. Okay. You mean now or in the session?
Maybe just briefly now. I just wanted to know what it was about.
Sure.
Maybe if you have a couple of minutes.
Yeah, sure. Just to give a very similar example would be the mouse. The mouse device that we use on a daily basis. This button here is called the left click button, and when as a user of a device, you only know that it's a left click button, and it's used to activate anything under the mouse pointer on your user interface, right? Now, the method of abstraction allows you as a user to be able to utilize that function without knowing the details behind that. In software development, there's a concept called big mud of code, or big mess of code. I can't remember. Big ball of mud, basically. You can Google that. It's a funny term. Basically, what it's saying is that some apps, it has all of the code interconnected with each other, so it gets really confusing. And abstraction in software development allows a developer to just simplify everything with just one method call. So that method call only does that thing, and the developer or the user doesn't have to know the details behind it.
Yeah. Okay.
Yeah. So in the case of a coffee maker, just make coffee, and you don't really need to know about the electrical wirings behind the device, or the timing of the devices and so on in the sequence of the process. So it really simplifies everything. So in the case of neurUL, just by knowing that you have spiked a neuron to call an ambulance, you don't need to see all of the neurons under that neuron to understand how it calls the ambulance. So does it make a call via a phone? Does it make a call via SMS messages or email? So it's all simplified for the grandmother cell, for example, or for the objects that spike those neurons.
Okay, thanks.
Great. Okay. Are there any questions? Other questions, suggestions for the next session? So you guys think these topics are sufficient for the next session? And do you think it will gradually build on the topics in neurUL 101?
I think you can always add more later if you find it's not enough.
Right.
Okay. It's better to start and not feel like you have to rush through anything because you're trying to have a time limit.
Right.
Yeah, I think it's quite a bit, especially the programming stuff will take longer than you think to kind of go through and explain.
Right. So most definitely there'll be a bit of a back and forth to understand and build on the ideas. Yeah. Okay. Cool. Right. Yeah. No problem, Sal. Okay. I think I think everyone is in agreement. I think we can proceed with this. I'll just build on this topics, and then please let me know if you're available next week. I'll just create a draft presentation for these slides, and in preparation for that session, I'd suggest that you go through the first, I think, 50 minutes, if not 40. I'll get the exact number for that video, but please go through that video because it's really important in our work. And thank you very much for attending this session.
Thank you.
All right.
Thanks, Elmer.
Thanks, Michael.
No worries.
Thanks, Richard.
Thanks for the presentation. It's pretty good.
Okay. Thanks, Richard. Thanks, Sal. Thanks for that.